Hello, this is day 2 of section 5.3. We will be graphing exponential growth functions. So here's our parent equation, 2 to the x. Now please note that you can have different bases. This one we're going to use base 2. And I will talk about what if you have different bases. So for this one, we are going to make a table. And I'm going to start with -2 for x. Now, students often just put in positive numbers, but the behavior on the positive quadrant 1 is sometimes very different than the behavior on quadrant 2. So always put, and quadrant 3 really, they're not all parabolic and symmetric. So when you do this, you're going to put this again into our exponent. So it's 2 to the -2. So remember, the negative is reciprocal. It's going to flip it, and then it's squared. So 2 squared is 4, and then the flip will be 1/4. And then 2 to the -1, again, that's going to flip it to be a half, or 1/2. 2 to the 0 power is 1. 2 to the first power is 2, and then 2 to the second power. And actually, you know what? I'm going to do 2 to the third, which is 8. Okay. So my parent graph is going to look like this. So we have -2/4, half, and 1. 1, 2, 2, 4, and 3, 8. So when we connect them, some of my students have said it kind of looks like a J. Sort of. Has this nice, it flattens out here as you go to x, as x approaches a negative infinity, it just flattens out, and then as it goes positive, and it just goes up, up, up quickly. So let's think about this. We know on this side, it's just going to continue up, right? What about this side? Will it ever hit 0? Will it ever be negative? Well, let's think. If I had 2 to the -1,000, well, it'd be 1 over a very large number, which would be a very small number. What if we had more zeros, more zeros? It's still 1 over something. So it'll be very small, but it will never hit 0. It will never be negative. So because of that, that's right, it has a horizontal asymptote. So it approaches 0, but it does not touch nor pass it. So we have a horizontal asymptote at y equals 0. What about our domain? All real numbers. Yes, we're writing it in interval notation. And our range is from 0 to infinity. Okay. So what are my key points now? And this is for transformations. I tend to use -1/2, 0, 1, always. And then for this, I have 1, 2, and 2, 4. Usually we only pick like 3 or 4 problems or points, right? I don't do anything smaller just because 1/4 is harder to show in graphs. So this is for the base 2 to the x. So what if we had 3 to the x? What does that do? Well, what happens is that it makes everything steeper, goes up faster, because it's a base of 3. And so my key points would be -1, 1/3, 0, 1, because anything to the 0 power, right, is 1. And then 1, 3, and then 3, 9. So hopefully you can see, right, where the bases are here, and the base over here. And hopefully you can extrapolate that and like what would happen if it was a base 4 or base 5 or base 6. All right, so let's talk about vertical and horizontal shifts. So if we're looking at this first one, this one is really similar to a function if we're doing parabolas, right? It'd be really close to this. where you can see what, right? That -1. But here, it's up here now, the x. But the 3 is still on the outside and at the end. But like all shifting transformations, it's still the same. So this is going to be up, and this is to the right. Right 1, up 3. Okay, so as the same as it would have been here and here, correct? Now I'm going to graph the parent function. Right here. Oops. Okay, and yes, you have to put the horizontal asymptote. This is a wall. Can't cross it. Can't touch it. Okay. Now, using transformations, I'm going to take every point and move it 1 to the right and up 3. Now, question is, do you also have to move the asymptote? Yes, you do. And actually, that's one of the first things I do. So if you move an asymptote 1 to the right, can you see the change of it? No, but you can see up 3. So this is our new wall, right? So again, moving all your points, I'm going to start here at 0. I always like this one first, 1 to the right and up 3. 1, 2, 3. And this one to the right, up 3. 1, 2, 3. This one to the right, 1, 2, 3. And my half, 1 to the right, 1, 2, 3. Right, because the half is right above the asymptote. And then again, asymptote. And I know I run towards it. And there you are. Okay. So let's talk about these key elements. Domain, all real numbers. Let's talk about the range and the horizontal asymptote. Now the horizontal asymptote is y equals 3. Don't forget the y. Yes, you need it. And if you don't have it, I will mark it wrong. So the range, if you see that, it goes from 3, the asymptote up. And it's not included, right, because it can't touch it. So it's 3 and to infinity. Note this and then this are the same. All right, so I'm going to draw the parent graph first this time. And it is base 2 still. And horizontal asymptote. So that's going to move it to the down 4. Again, this is plus 5, just like inside a parentheses, so it would be to the left. 5. So I'm going to drop down my asymptote by 4. We're moving all the points 5 to the left and then down 4. So I'm going to take my 0, 1, 2, 3, 4, 5, and then drop it 4. This one is 1, 2, 3, 4, 5, and drop it 4. 1, 2, 3, 4, 5, and drop it 4. And then my half. And there you are. So domain range, and yes, I will ask you for these things on your homework. Domain for every function, range. So all real numbers. So negative infinity. Now the range, so where it goes from -4 and up. So not including -4. It's open parentheses, or O parentheses, infinity. And then this is y equals -4. Again, this number is the same as that. Okay, I'm gonna graph my parent graph. Now, I know students think it's tedious, but if it's a new graph, oops, here's the other thing. Oops. What is my, I almost did 2, but is it? Nope. because now my base is 3. So it's not a half, it is 1/3. Though on here, I don't know if you can really tell the difference because the distance between my lines are pretty small. I think that looks better. So remember, this is what we're graphing, but our parent function for this is 3 to the x, right? So 3 to the first power would be 1, 3, and then 2, 9. So to see it goes up faster. The other one would have been 2, 8. And as you get higher, it goes up even more quickly. There, it flattens out. And the asymptote is still the same. So what does this negative do? What does a negative do in front of everything? Right, it reflects it over the x-axis. Now, does it change the asymptote? No, because when you reflect over, it is the x-axis, right? Y equals 0. So reflect it, your points will be coming down. So it'd be 1, -3. So literally that negative, right, makes all the y values negative. There you go. All right. So domain, all real numbers. I know you say negative infinity and infinity to me, but we say all real numbers. Okay, so we're going from 0 to, no, we're not. Haha. See, you're right. See if you're paying attention. So you're going down. So, oh, we're right. No. So which one's smaller? Negative infinity. So that one's going to go first because we're really not going that way. I think that's what people think. But really, for this one, we're going this way because we're going from small to larger number. So that's to 0. Okay. And then horizontal asymptote y equals 0. So this time the 0 is on that side because it's going down. Okay. All right. So paragraph 0, 1, 3, 1, 3, and then 1, 9, negative 1, 1, 3. And asymptote. Okay. So what does the negative do? Now it's at the x. It's up here. It's not in front. We did this with square roots. Parabolas you couldn't see very well, but square roots we did and confused some of us. So it reflects over the x-axis or vertically. So this point stays the same. But this point over here, it gets reflected across the y. This point gets over here. And then this point is now over here. So it's going down like a slide. This is also what an exponential decay exponential decay graph looks like. So it's going down. The asymptote is still the same. All right. And then for this one, the domain, still the same. The range, right, smallest to largest is going that way. 0 to infinity, and y equals 0 for horizontal asymptote. There we go. So again, the difference between negative in front and a negative with the x. All right, so here's just a summary of the different shifts. Now, if a is positive, we get our regular j exponential shape, right? So if it's moving left or right for h, remember it's opposite sign. So if you see a -3, that's actually to the right. And if it's plus 3, it's to the left, again, for the H. But the K, the sign is the same. So if it's plus, it's going up. If it's negative, it's going down. Okay? And answer the essential question. Thank you for watching. Bye.